Once we have done good abstraction, we have learned how to see the commonality between objects and create classes, including attributes of classes derived from attributes of objects. And then we see how uh, a frog and a cat are derived from animal, and we start moving the common attributes of cat and frog to animal. Reuse, improved quality, much better code, easier to maintain. So that leads us to inheritance, which is one of the most important concepts of object orientation. Languages like C++ and Java allow us to create inheritance hierarchies. Again, we have to take care that we don't go too deep into the user created, that is the programmer created hierarchies. Otherwise, although it sounds exciting, it can be difficult to maintain. Encapsulation is another very important fundamental of object orientation, and now for any program design. What it means is the data within your class, that is the attributes within your class, cannot be modified by another class. Now obviously the modification will happen when the classes are instantiated at runtime. But in earlier programming languages, C and COBOL for example, we could play around with the attributes anywhere in the system. In a way, they could be treated as global attributes. But encapsulation makes sure that the attributes are wrapped around by meaningful methods or meaningful functions. You can call them whatever you want. A key thing to remember is if you create a function for each data attribute, it's nothing but data hiding. What I am encouraging you to think of is meaningful functions. So for example, if you have a date attribute and you create a method called date, which is create date, modify date, delete date, then it is just data hiding. But if you have a function or a method in your class that allows another class to come in and do date mathematics, subtract two dates and find out the number of days in between, minus public holidays in a country or in two countries for currency options. Now that is a date math that is meaningful encapsulation of date. But even data hiding has some value. And then when you have an inheritance hierarchy like animal, and you have specialized animal into frog and cat and horse, and then you instantiate, you create runtime objects. Those runtime objects will obviously be either a frog or a horse or a cat, whatever it might be. The object that sends a message to frog or cat or horse need not know whether it is a frog or a cat or horse. It is simply one single message which can then be interpreted depending on which object has been instantiated. That is the fifth object oriented fundamental, polymorphism. Polymorphic objects means the receiving object is the one that deciphers how to execute move for a frog or move for a horse, and the object that is sending the message need not worry about the receiving object. Now this does sound great in theory, but in practice when we implement polymorphism we have to take extreme care. So those are the 5 fundamentals I want you to learn, create examples, ask me questions. And then the second part of this chapter deals with agile methods, basically organizing your project. So software development life cycle and the role of composite agile. Composite agile is a research based creation with one or two of my past PhD students. And composite agile goes through the formal linear life cycle up on top, then goes into iterations, then creates increments, then goes into iterations, and right at the base it applies agile practices. Of course, to organize any project, whether it is software development, whether it is building a house or manufacturing a car, you need to break the project down into smaller parts, and the smaller subsystems of your project in UML are represented by packages or package diagrams. So that is what we are going to learn in this chapter. I hope you find the chapter valuable and continue to maintain your interest in learning good program designs with UML. This is Bhuvan Unhelkar. Thank you. Bye.